Earth's climate is chaotic and noisy.
Finding usable signals amidst all the noise can be challenging, be it predicting if it will rain, knowing which direction a hurricane will go, understanding the implications of melting Arctic ice, or identifying the impacts of human-induced climate warming.
Climate scientists use a range of tools to detect signals in the Earth's system.
In the Barnes Group, we use machine learning, specifically neural networks, to sift through vast amounts of climate data and find predictable patterns in the noise. Neural networks learn from existing data by taking in information, processing it, and then making a prediction.
But is the prediction right? How did the network come to its conclusion? We use methods in explainable AI to answer these questions. These methods propagate information backwards through a network, starting with the prediction and deciphering the network's decision-making process along the way.
This allows us to not only gauge the trustworthiness of the network's decision, but also uncover predictable climate signals we didn't know were there. That is, we can learn new science.
These machine learning tools can be applied to solve a variety of global problems that affect large populations and communities. For example, the position of the jet stream pushes many storms across the mid-latitudes, providing people and agriculture with fresh water. But its position will likely shift as the planet continues to warm. Understanding where storms will go is crucial for future community planning. We can utilize the capabilities of neural networks to investigate the relationships between warming patterns and a variety of climate change consequences, including the location of the jet stream.
In order to prevent the worst impacts of climate change, humans are studying methods known as climate interventions in order to either reduce greenhouse gases in the atmosphere or directly cool the planet. Neural networks can help us to understand how the Earth may respond to different climate intervention scenarios and identify what climate patterns are associated with an intervention. This knowledge can help guide public discussion and governance of our responses to climate change.
Machine learning can open new doors to understanding and predicting Earth's climate, both now and as the climate continues to change.
But even the best machine learning model is only as smart as the scientists designing it.
Building the future of climate science requires a diverse set of voices, diverse set of backgrounds, interests, skills, and creative ideas.
This includes mathematics, physics, computer science, atmospheric science, meteorology, earth science, economics, sustainability, to name a few.
Working together, we can tackle some of the world's most pressing questions about Earth's climate.